So I just started the stream and I'm going to go ahead and oh, I already shared my screen so you can see this. Okay, cool. So what I'm going to go ahead and do is make a test here. And like I mentioned, we're on chapter 3, day 4. So this is going to be resource and struct interfaces, all right? So just like we talked about in the last workshop with resources, let's say we have a resource called profile. And inside the profile, we have like an ID. We have, actually, you know what? We're going to use NFTs today. We're going to slowly transition into NFTs. So, like we talked about in the last workshop, sometimes what we want to do with resources is represent them as NFTs, right? Because resources are, they represent assets or they represent important objects on the blockchain. And so in this case, an NFT is a great, it's a great use case for a resource. So we're going to give our NFT an ID. We're also going to give it a name. And these are going to be the only two things we're going to give it for now, right? Pretty simple. And so what we're going to do is set the, we talked about this in the last workshop. We're going to set the ID equal to the UUID. So this is, just to recap what this is, every resource on the blockchain has what's called a UUID or a unique identifier automatically. So you'll notice it's kind of weird. We're saying self.uuid and you actually can't see that here. Like you're saying, wait, where is the UUID? Well, actually, it's here. You just can't see it. And in fact, if we actually try to do this, you'll see it says cannot declare field here, UUID, and that's because it already exists. So you can't put it again because it's actually already there. It's just hidden. So kind of weird, but also that's how that works. And we're going to pass in a name and just set self.name equal to name. Okay, just like that. So here is our resource sort of like object, right? Cool. Now, actually, let me see what example do I use here? Okay, so this is a resource. Now, the interesting thing is what we can do is make something called a resource interface. So we're going to explain what interfaces are in a second, but let me just quickly, put it here so you actually can see what it looks like in code. So when we, I'm sort of working backwards, right? So we're going to see it in code and then go back to what it means. But a resource interface is something that basically sits above a resource, like in theory. What it does is it specifies a bunch of requirements of what an NFT should have, and also like what. Actually, yeah, we'll get into that in a second. So when we look at this diagram, you'll see that, this is the resource or struct here in this blue box. And this purple thing is the interface. And you'll see that the terminology we use is that a resource or a struct, quote unquote, implements a interface. Okay, so in a sense, this resource implements or uses this resource interface. Okay. Now, there's two use cases for an interface. Either one, it specifies a set of requirements for something to implement. So what that means in more plain English is, if an interface has some field or some function inside of it, then whatever resource or struct is implementing it must also have it. So it's like a requirement almost. And also, it allows you to only expose certain things to certain people. So we're going to slowly get into security and this thing called access control. And that's how we're going to boost the security of our contracts, which is like a main topic in Cadence. So what do I mean by that? Well, the first one is that it specifies a set of requirements for somebody to implement. So what does that mean? Well, let's say inside of here, I had something like public let ID as a UN64. Okay. Now, so far everything is fine. And let's say I also want this to have like a fruit. I don't know. And this is gonna be a string type. Now, what's going to happen is if I tell this NFT resource to implement this resource interface, the way I do that is I put a colon after the resource and I put the resource interface name. Now, the second I do that, we're going to get a problem, right? So right now, what just happened, if you're like a more of a visual learner, is we just created this arrow. So we just told the NFT resource to create an arrow to the purple box. So that's what just happened when we did this part right here. Also, hey, Biomech. Um, so there's a problem. It says resource hello world.nft does not conform to the resource interface. Now, the reason for this is because, well, the resource interface is saying, okay, whatever implements me has to have an ID. That's a UN64 type. Okay, we have that. But it also has to have a fruit. But we don't have that in this NFT. That's a problem. So we actually have to put fruit in here as well, and now we're not going to get any errors, or at least we have to initialize this to like some like a watermelon or something, and now we don't get any errors. Now, a common question I get sometimes is like, why don't we have to put in a init function inside of the resource interface, right? Like, Jacob, you always said that you always have to initialize your variables. Well, that's not the case for interfaces because interfaces are not like, they're not actual things. They're more abstract, like requirements that are put on top of, existing things. So in this case, this NFT here, this gets used by people. This gets passed around. People can hold on to NFTs, all that stuff. This resource interface is purely used for code. It's just a requirement that other code that actually is going to be useful has to implement. So that is that's what this is doing. And in the future, if you wanted to add more interfaces to this, like let's say we had another one here called INFT2, and in this one we said, okay, you have to have I don't know, let's say like a favorite book, which is a string. Then well, now we're fine. But if we say tell this it also to implement INFT2, then all of a sudden we have to bring this down as well, right? And we would have to initialize this and say, okay, self.favorite book equals I don't even know if I have a favorite book. Maybe Ready Player One, right? So there you go. But just to keep this use case pretty simple, we're just going to only have one resource interface for now. So we're going to get rid of this, and get rid of this too. Okay. So that is what an interface does. So that's at least part one, right? It specifies a set of requirements for something to implement. But there's a second use case, and this is the way more important one, number two, is that it allows you to only expose certain things to certain people. So again, this is where, so I think we already covered all of this, right? We already covered all this. Okay. So this is where we start to get into the security of our contracts, and this is really, really important. And also one of the reasons that Cadence is a lot better um, than Solidity. Okay, so let's make a function down here. This is just for testing purposes, called uh, create NFT. And what's going to happen in here is we're going to say let NFT. We're going to create an NFT, right? We covered this in the last workshop, how to create resources. And, what we're going to do is, first we have to pass in the name here. So let's just actually, yeah, so to pass in the name, let's just pass in Biomech. All right, Biomech, you got used as an example. And in here, the type of this is going to be an NFT type, right? So again, we covered in the last workshop that all resources have the @ symbol in front of them. That's their type. Okay, so that's what it's going to be. I will be in every recording. Yeah, you're going to be. Exactly. So that is what the NFT is like, okay? Um, now, what we can do is we can, let's just down here, let's just, of course we have to get rid of the error. It's just loss of resource. Remember, we learned how to solve this. You have to put it somewhere. So in this case, by putting it, we're just going to destroy it, which is much easier. But inside of here, before we destroy it, let's actually read nft.id. Let's also read nft.name. And let's also read nft.fruit. Right? All of these things, it's not giving us any errors. So we can correctly log all of these things. That way, again, log is only used in local development. But if we were to run this function, it would log all of these things. So we would see an ID, we would see a name, and we would see a fruit. And that's totally fine, right? Because this NFT type right here has an ID, name, and fruit. So pretty easy. But things get a little complicated if we were to try something else. So let's copy this function and say create NFT or create restricted NFT. Now, the only thing we're going to change here is we're going to change the type to also abide by the interface. So the way you do that is you put curly braces and then you put the name of the resource interface inside of it. So in this case, INFT. Now we get a problem. The problem is, okay, we can, we're correctly reading NFT.id. We're correctly reading log NFT.fruit, but it's not letting us read NFT.name, right? Member of restricted type is not accessible. Name. Does anyone know why it's not letting us log name here? Why is it not letting us access name? And you can take a look up here. Hey, June. Yeah, it's also I see Meaning Green here. What's up? I love that name, the Hulk. But yeah, that's exactly why. It's because name is not in the interface. So if we were to add it here, Now all of a sudden we're totally fine. We get no errors, right? We can correctly read the name of the NFT, so we're totally good. Okay. Now this also applies to functions, by the way. So let's say we had a function called change name, and we took in a new name, which was a string, and we said, okay, self.name equals I don't know, Johnny. Let's change to var, right? So if we were to down here call that function and say, in the create NFT one where it's not restricted, we could say nft.changeName and pass in a new name, which should be Johnny. Also, I just realized that it doesn't make sense to pass in a name and then not change it here. So let's just say new name. Okay. And we go ahead and change the name, and now, there's no errors here. But if we try and do that in the restricted one, it's not accessible. And that's because this function change name, if we scroll up here, this function is not available inside the interface. So the way you add a function to an interface is actually a little strange. It's the same like first line, so change name, new name, string, but that's all you put. So you don't even put like the open brackets, nothing, because again, in an interface, not only do you not have to initialize your variables, but you don't have to implement your functions either, right? All this interface is saying is that you have to have a function that called change name, right? It's public. It has a new name argument that's a string type, and then maybe if you had a return type, like if you're returning an integer, I don't know why, but you were just like, okay, let's just return 1, then you would also have to put that right here. So you just have to tell it what the function's, going to do, but not actually like what it's supposed to do. Or like, like you don't have to actually implement the stuff inside. All right. So that is interfaces for you. Do we have any questions on interfaces? And again, you can read through this example for it's actually not the same example, but it's a very similar one if you wanted to check it out. But that's all for chapter 3, day 4. And I'll pause for a couple minutes on that because we're actually going to move over to a totally separate topic. All right. I'm going to put a little thumbs up in the chat. And if everything's all right, go ahead and thumbs that up. And if you have any questions, go ahead and thumbs that down. Don't be afraid to thumbs that down if you need, just to make sure everyone's doing all right here. All right. Cool. So I'm taking a quick break just because I'm also trying to figure out how to start teaching the next lesson. But I think I understand. Okay, cool. All right. So like I said, we're gonna move over to a totally separate topic, and this is gonna be called access control. So nothing to do with really interfaces, but totally separate. So this is my personal favorite thing about Cadence, and I think this is the what we're going to learn right now. I think is what makes Cadence like arguably the most unique between Solidity and all these other languages. And it's also crucial when we think about like smart contract safety. So I think it's going to be really interesting, both for people that are looking to implement their own contracts or, be able to read contracts and find security leaks. This is also something that's incredibly important for auditing. So when you sit, what auditing basically is like when you take your contracts and you pay like a so-called auditor to review your contracts and tell you if there's any security leaks. This is like the main thing that a auditor will look for in your contracts is the topic we're about to cover. So far in this course, what I've taught you is to totally ignore this pub statement, right? And we've noticed trying to get rid of errors here. Also, let me mute that. But let's just say self-greeting equals I'm smart. Truth. But I've told you to totally ignore this pub, right? We know what let means, right? We can also put var here. We know this is the name of our variable and this is the type, but we haven't really understood what public means. And this is something called an access modifier. So we're going to spend the next like 35 minutes or so going over access modifiers and the different ones you can put here. So just as a sneak peek, there's access self, there's private, there's access contract. There's a bunch of them we can actually put here that are gonna, they're all very different and they're crucial in understanding what they do. So to do that, we're gonna pull up this really helpful diagram. This diagram contains pretty much everything you need to know about access modifiers. So if you ever have any questions, this is the place to be. Now, we need to sort of get in the mindset of like a new way of thinking. Okay, so in your head, I want you to think of where can I read this variable and where can I change this variable, or we call it writing. Where can I read this variable and where can I write this variable? So again, writing means like where can I change it? So right now, the one that you all know and love is pub, and this is what we call public. Now, what this means is that we can read this from anywhere. Okay, so we can read this greeting in the contract, we can read it in the transaction, we can read it in the script, but we can only write it inside of where it's currently written. So because it's written at the top level of the contract, we can write to it anywhere in here, but we can't write to it in the transaction or the script. And I'll actually show you that. So if we were to go to a transaction, well, let's first deploy this. And let's go to a transaction. And let's try to say, okay, hello world. Well, I'll show you actually. So we can read the greeting by saying hello world dot greeting, right? Or log, like let's just like read it. So it's log hello world dot greeting. But if we try to say hello world dot greeting equals this doesn't work, we can't do it, right? So we cannot write the greeting. And you'll see it says, okay, cannot assign to greeting because the field has public access. Consider making it publicly settable with pub set. So we'll talk about that in a second. But the main point here is I want you to get in the mindset of in which cases scenarios or in which access modifiers can I read and write this variable, okay? So let's go to this diagram. Now, one other little caveat here is that this diagram has, a section for let and a section for var. Remember, that's what you put right here, let or var. But as we all know, let means it's a constant, so you can't ever write to it. So we're not going to cover this, and I'll tell you why. It's because it's sort of a boring example, because obviously with let, right, look at the right-hand column here, the write scope. You'll see it's none for all of the ones with let, right? And that's because you can't change a let variable. It's a constant. But so we're gonna stick to the var examples because they have the same exact read behavior as let, but they all have unique write scopes, and this is what's interesting. So we're just gonna stick with the var examples for now. Okay. So the first one that we wanted to cover is this right here. It's pub and this other thing called access all. So you may have seen, actually, you'll see in the boilerplate contracts they give you, they actually write access all everywhere. To me, it looks sort of ugly. No offense to access all, but it's the same exact thing. So if you write public or you write access all, these two things are completely identical. There is literally no difference between them. So if you ever see access all, it's the same exact thing. And what they mean is that, this row right here, it means that the read scope is all, so we can read it wherever we want, but the write scope is something called current and inner. So I'm going to try to explain to you what I mean by that. This was my diagram from before. But I'm going to try to explain. Also, why is my... I don't even know why this is so weird. Okay, but I'm going to try to explain this to you. So let's say this is the contract. Okay, just like this. This is the contract right here. Now, what happens is we currently have something called a greeting field inside of here. Okay. Now, this is the contract. And then let's also imagine that there's transactions. Oh, thanks, pal. Have a good meeting. See ya. So yeah, that is the transaction, right? Okay, so let's say this is a transaction and this is a script. All right. So picture like 3 different things going on. Okay. Now, what this means, right? All means literally anywhere. So it can mean in here, it can mean in the transaction, in the script, over here. Like it can mean literally anywhere. Now, current and inner means only at the current level and inside. So not over here and not over here, right? Those don't work. So that's what current and inner means. Now, the reason that we say that, this might be a little confusing, is because let's now imagine that we have a resource here called profile. And inside here, we have like a public let name, which is a string. And let's just quickly initialize this to self.name is always, or let's just make it more proper by just passing, let's just pretend we pass in something here, right? Look at this public. Now you might be asking, what does this public mean, right? If this public, the write scope is current and inner, can we write it like over here, for example? No, because let's draw another box. And I'm going to make this a new color. So it's blue now. And inside here, we have pub let name is a string. In this case, current and inner means inside this box. So only inside the resource, but not outside in the rest of the contract. No, can't do that. Okay. So we wouldn't be able to write the name outside like in here or over here. Can't do it. But because the read scope is all, we can read anywhere. So we can read it in here, transactions, script, wherever you want. All right. So because this is a first example, this might be a little confusing, but we're going to get the hang of it because we're going to walk through all, like literally all of these. Okay. So let me go ahead and, yeah, okay. So we're going to go on to the next one now. So let's go over public set. So public set, let's change greeting to a public set. Public set is interesting because what this does is this has a read scope of all and a write scope of all. So I'm going to quiz all of you, right? If this has a write scope of all, can we change greeting instead of a transaction? Who says yes and who says no? Thanks, Biomac, for the answer. Actually, I'll put a, yeah, yep. So people are saying yes, yes, yes. Yep, exactly. So the answer is yes. So you can change greeting inside of a transaction. Let's try it. So if we were to deploy this contract, right, confirm, let's go to transaction and refresh the page. Look at that. We can change it. So do you see how dangerous this is? Because if you accidentally leave a variable that's public set, anyone can change it. So that's really dangerous, actually. So my best piece of advice, sort of as a side note, is to really never use this. There are really specific cases where you would use this, and I've done it before. But other than that, I would try and stay away from this at all costs because it can be very risky. And usually when someone's auditing your contract, the first thing they do is look for this because it's pretty dangerous. Okay, and also the read scope is all, so that's also pretty obvious. Now let's skip down to access contract. We're going to come back to access account later, but I'll tell you why we can't go over that together. So access contract, okay, let's try that. Access contract. So access contract is really interesting, and basically what this means is that the write scope is current and inner, so just like public we went over, right? So if this is access contract, I'll have to expand this box a little bit. Okay. But if it's, oh, oops. So if this is access contract, what this means is that the write scope is still in here or over here, only inside the contract. But the read scope is current, inner, and containing contract. So this means, right, when it's at the top level, right, it's current, inner, and also the entire contract as a whole, which is really the same thing when it's at the top layer. But what's pretty cool is that if, for example, let's say this was access contract. then what this means is, let's go ahead and expand this box as well. Access contract. This is var. What this means is that the read scope is not only in current and inner, but it's also in the rest of the contract. So it can be like over here or over here, but the second it steps outside the contract, nope, you can't do that. Nope, nope, nope. And you can't go over the script as well, so can't do that. Also, in my opinion, I think I actually wanted to make a YouTube video on this because I think that access contract is extremely powerful, and not a lot of people use it actually. So I kind of want to make a video on why. But yeah, okay, that's access contract, and the last one is access self. Now they don't list it in here for some reason, but when you see access self, it's the exact same thing as private. So if you ever see access self or private, they are the same thing. But weirdly enough, I've said this in all my previous workshops, but weirdly enough, no one ever uses private. I've never in my whole 2 years of coding Cadence ever seen someone use private. They always use access self. I don't know why. It's pretty weird that people use public instead of access self. But then when they go to use, or no, I'm sorry, it's weird that people use public instead of access all. But when they go to use private, they use access self and not private. I don't know why. Literally no idea. But anyways, that's just part of being a weird, quirky Cadence developer. Um, so access self, what this means is that the read scope is only current inner and the write scope is current and inner as well. So what this means is that if we're inside of, let's say, inside of profile, let's say we're changing this one to access self. What this means is the read scope is now only in here. You can't read it out here. Nope, that's not allowed. And you certainly can't read it outside here or here. So with that being said, let's actually, the way that this usually clicks in people's heads is we're going to scroll all the way down. And again, if you want more examples, definitely check these diagrams out. They're really helpful. But the way that this always clicks in everyone's head is if we go to the quest here, because once we do the quest, people always get it, or they're at least closer. And then let's also copy the script. So the reason this lesson is so fun for me is because what ends up happening is we turn the rest of this workshop into like a quest, and it's almost like a treasure hunt. So let's play a fun game together. Okay, so what I have here is a contract called some contract, and I have a struct here called some struct, right? And inside of some struct, we have 4 variables. We have A, B, C, and D. Each of them has a different access modifier, right? And we have 3 functions: public func, access or contract func, and private func. And what we're going to do is we're going to go through 4 different areas: area 1, area 2, and area 3, and then the last area is actually in the script. Okay? We're going to go through each area, and in each area, you're going to tell me which variables and functions we can read and which variables and functions, or at least which variables we can write. Because you can't write a function, but you can call it, right? Which is like the same thing as reading. Oh, nice, roster. Thanks for pointing that out. I'm glad you're watching on YouTube. All right, so let's try with area 1. So inside of area 1, tell me which variables we can read and which ones we can write. Okay, let's do the read ones first. So who says that we can read? Actually, and you know what we're gonna do? We're going to draw a box. This box is some struct. I believe the contract is called some contract, right? And we're currently in here. So we have public let A, access contract. Wait, what is it? Oh, sorry. Public set var A, pub var B, access contract var C, and access self All right. And I'm asking you, you know, right, based on, the fact that these variables are inside of the struct, we're currently in another function, right? Some struct area 1. Okay, so we are inside of a function right here. I'm going to make this a new color. And this is called sum function, right? Oh, struct function. Okay. So inside of struct function, which variables can we read? Can we read A, right? Public set, this one is. Okay, let's go to public set. And the read scope is all. So who thinks we can read A instead of struct func? So Cheetah says yes, because Cheetah says we can read 1. I'll put a thumbs up in the chat. Who thinks we can read A inside of here? We have 3 yeses, 4 yeses, 5 yeses. Good. Yes, we can certainly read A inside of here. Okay, what about B? And use the same reaction. If you think yes, keep it as yes. If you think no, change it to no. So who thinks we can read B inside of here? Okay, people are saying with yes. Good. We can definitely read B inside of here. All right. What about C? Can we read C inside of here, right? So let's go to access contract. Access contract is current, inner, and containing contract. So does that count for this? Yep. Okay. People still say yes. Now, what about D? What about D? Let me put another thumbs up in here. If you think we can read D inside of here, click the thumbs up. If you think no, click thumbs down. Can we read D inside of here? Now let's go to D, access self. So access self is current and inner. Can we read D in here? So 2 people say no, 2 people say yes. Who's going to break the tie? We need someone to break the tie. Need one more person to vote. All right, we have people are currently in the positive. The answer is yes. We can read D inside of here. And that's because, remember, access self has a read scope of current and inner. So, this is at the current and inner level scope of where we are. So we can definitely read here as well. So if we go back to our answer, it's A, B, C, and D. All right, but now what about write? Right? Well, we can kind of go through this quickly because remember, we just decided that, like, if we go all the way down to where we were, access self, right? This has current and inner scope, and we agreed that we could read, right? We could read in here. So if all of these also have current and inner for write scope, well, that means that the answer is yes for those too. So we can definitely read all of them as here as well, or write all of them here as well. Does that make sense to everybody? Okay, cool. So let's go to area 2. Now, area 2 is definitely going to be a little more complicated. And the reason for that is because we're in a whole new, different part of the contract. So we're now over here, and let me make this blue again because it's at the same level. This is called some resource. I think it's actually the wrong color blue. What blue did I? Oh, yeah. Okay. So now we're in here, and more specifically, we're in something called resource func. So let's just copy this over. Okay. Cool, right? Now we're in here. So let's look at these variables again and see if we can read them. All right. So first, we're gonna ask which ones we can read. All right. So which ones can we read in area 2? So if we go to A, right? A has a read scope of all. So can we read A in here? Yes, right. As we go through these examples, if something says all, the answer is pretty much always yeah, right? Because it's just all. So we can obviously read inside of here. Now for pub, it has the same thing. It's also all. So yeah, we can also read B in here. So far we have A and B. But what about C? C says that we can read in the current, inner, and containing contract. So is this in the containing contract? Yeah, right? It is. Good job, everyone. Yeah, it is. Because, this is definitely in the contract because we're in the contract right now. So we can definitely read it. So yes, the answer is yes for C as well. So let's add C. What about D though? Can we read D in here? D says current and inner. Is this in the current and inner scope of D? Like inside here? No, it's not. It's somewhere, it's outside the box. So the second we go outside the box, the answer is no. So we're not going to put D here. Okay. What about writing? So for writing, well, for obviously all for public set, so that's always going to be yes. So A. But when we go to the next ones like current and inner, current and inner, current and inner, we just decided that this was not in the current and inner scope of where these variables are. So the only answer for writing is A. How's everyone doing? Good? I'm gonna put a thumbs up in the chat if you understand all this. Thumbs that up. If you're struggling, you can thumbs that down. And I'm gonna set up the next area. The next area is actually a function called quest or fun. Right? So this is actually a function right here, area 3. So we can kind of go quickly through this one, but let's try it. So with A and B, right, they both have all scope for reading. So obviously the answer is yes. So read, right? We know for reading, the answer is A and B, of course, because they're both all. What about C? C is access contract. So for reading, current, inner, and containing contract. Is this in the containing contract? Yep, it definitely is. So we can definitely read C in here. Okay, so we can add C to that. And with D, right, we already decided that the current inner scope only applies in here. So we're not going to be able to go outside the box over here. That's not going to work. Can't do that. So we're not going to put D here. No D. And then with writing, right, we also decided that the only one that would, most like, or the only one that can write is public set, because the other ones, current and inner, current and inner, current and inner, never works. So only the one with all. Okay? So the only one is A. And that's area 3. Now, the last area is actually in the script. So the last area is over here. All right? So this is where things get a little tricky. So over here, right? Who thinks that we can, all right, let's just go through each one. So public set, right? Public set is all. Can we read, go through the read ones first. Can we read A in here? We can read A, right? Because it has all. And so if we can read A, then we can definitely read B because they're the same thing. They're both all. So we can read B as well. Now, what about C? C says current, inner, and containing contract. Can we read C in here? I'm gonna put a thumbs up in the chat. Who thinks we can read C in area 4? Who thinks that we can read C in area 4? We have 2 yeses and 3 nos. So I'm gonna explain this one more time, and we'll see if some thumbs change. So C, right? The read scope is the current, inner, and containing contract. So is this current, inner, or containing contract? Oh my God, we have a crazy tie going on. All right, instructors, you're allowed to vote. The instructors are now allowed to vote. What do the instructors say? Look at this tie going on. This is insane, actually. So to the 7 of you that said no, you're correct. The answer is you can't, because remember, like I was saying here, current and inner scope only applies to, within that box, right? And this is definitely not in the containing contract either, because we're outside the contract, right? We're in a script now. So the answer is no for C. Okay, so we don't put C here. And then we obviously would not put D either, because that's even more restricted. All right, so now let's go ahead and think about right scope. So who thinks that we can, I'm going to put a thumbs up in the chat here. So no one feels is cringing right now. Who thinks we can write A inside of the script? Write all. So no one feels is cringing. Okay, Cheetah. What does everyone think about what Cheetah just said? Is anyone going to change their minds to no? Or are we going to stay with yes? All right, I saw we had 7 votes. Now it's gone down to 6. Does anyone else from the yes side want to transfer over to the bad side? Or does the bad side want to transfer over to the good side? So the answer is no, exactly like Cheetah said. So we can't write A here. It's a trick question because even though it's all, it doesn't matter because we're in a script. So you can't here, because you can't write anything. So this write is going to stay completely empty because you would never be able to write anything in a script anyway. Of course, if we were in a transaction, right, if we were over here, then the answer would be write A. We would be able to write A in here, but nothing else. All right, so that is, oh no, we have a couple ones left. We have the functions now, but for functions, it's actually quite similar. So for each area, we'll do functions now. But when you think of functions, think of it's exactly like read scope. So with functions, public, right? The call scope. Actually, there's a whole separate diagram if you want to look at it. So if we go back up to the diagram real quick, uh, it's this one right here. So it's like oh wait, we have to scroll. It's this. So this is for functions. So it's the exact same as read scope. So yeah. So all is public and access all. So obviously for public, the answer would be public func. And also because we're in the current and inner scope of all these functions, it's going to be for all of them. And also private func. So all 3 work in this one because we're all inside of the current inner scope right here. But when we go to area 2, it's no longer going to be private func, right? Because we're no longer in the current and inner scope of these things, but we're still inside the contract. And obviously for public, it's all, right? So that's going to work for these 2. And the same exact thing for this over here for area 3, because in area 3, right, this is all, and this is also still in the contract. But when we go to the script, then all of a sudden it's only going to be public func because we're no longer in the contract. And I went through that pretty quickly because it's literally exactly like read scope if you want to go back and check that out. And also notice that there's no such thing as public set for a function because you can't write a function. Like, that doesn't make sense. Now, also, the only one I left out, I told you I would come back to this, is access account. So the reason that I didn't talk about access account, actually, if we look at it, it's pretty similar to access contract, except instead of it current inner and containing contract, it's current inner and other contracts in the same account. So it's a little less restrictive than contract. The reason we couldn't do this in the playground is because in the playground, you can only deploy one contract per account for some reason. They're changing it though in the future. And you can only deploy one contract per account, but in a real scenario, I always show this example. So what we're looking at right now is a live example of all the Flovitar contracts. So this is an actual account on the Flow blockchain. This is on mainnet. So every time you run a transaction or mint a Flovitar, it's using these contracts right here. You can actually look at all their source code. It's pretty cool. Um, and by the end of the boot camp, I think you should be able to understand all this stuff. But anyways, you'll see that under this one account, there's 5 different contracts. So that's very different than the playground, where under each account there's only one contract. In the real world, you can have as many as you want. So what access contract means is that, for example, if we were to change this to access account, what that means is that we can read this in any of these contracts. So not just this contract, right? If this was access contract, we can only read this inside this contract right here. But if this was access account, we could read it in any of these contracts. And then any other contract that's not in this account, we wouldn't be able to. So that's what this means. And you'll see this a lot more like in production environments. Yeah. And actually, sorry, the last thing I want to mention is that there's a really common misconception that people get from me teaching this lesson. Sometimes people come out of the session and they're like, "Oh, okay. So if I make this access self, you're telling me no one will ever be able to read like private information I put here?" Right? So like let's say for example, I put access self var d is or access self var password var string, right? And I do this. People always say, well, okay, because it's access self and you can't read it in a script, no one will ever be able to read it, right? The answer is no. Every single thing you put on the blockchain is public. So remember back to chapter 1, don't get it twisted and don't like trick yourself into thinking that just because you add an access modifier, that means it's no longer viewable. These access modifiers only apply in the context of Cadence code. So yes, you won't be able to read this password inside of a script, but if you were to return this entire object to a script, you would be able to read this in the object. And, or if you were to go and, theoretically, if you were to go and look at blockchain data, right, and you were actually to go and do like a block, a certain node or a certain block and read the information that was changed on the blockchain, you would be able to read this. So don't, trick yourself into thinking that just because you have an access modifier, your data is now private. That's not the case. It's always public. It's just that this only applies in the context of Cadence code. So with that being said, I'm going to go ahead and make the float. That is all we have for today. And I'm curious to hear what people are doing for their weekends. What's everyone up to this weekend? Going in Oregon? Nice. Smart contract review? No, no. Actually, maybe on Sunday. Actually, maybe on Sunday. 'Cause I'll be back in Chicago then. Cheetah is still sending support monkey chat. Lavish says watching football. Ooh, what team? Go Steelers. Rams in all caps. I can sense your enthusiasm, chat. I have to give one interview. Oh, no, what are you interviewing for? Going to Sunwaves Festival. What is that, Biomech? How many people are here? Like 20? Secret code is going to be hub. For internship, ooh, what internship are you applying for? Full stack web dev. You're going right into the rabbit hole. Cheetah, have you ever thought about like looking for cadence opportunities maybe? You know, if you didn't get that, I mean, I pray you get that for your sake, but you've been doing really well in the boot camp so far, and I have no doubt you'd be a good cadence dev. Don't sell yourself short. I hate front end. Yeah, so why are you doing it? The password is pub. That's the password for the float. I just sent it in the chat. Only 20 available, so be quick before the bots come and ruin everything. I'm also gonna